Welcome to the presentation that is about to be presented by Group 14. The topic for our data science project is mutual funds. I am Pradipti Mondal and the other team members are Aman Jha, Garv Jain, Fersha JJ, Kanishk Giri and Gargi Chandraker. So, talking about mutual funds. Mutual funds refer to a pool of money collected from many investors to invest in securities like stocks, bonds, money market, instrument, etc. on the behalf of investors by the mutual fund companies. Now, the important terms used in this are NAV, that is the net asset value, which is used to identify potential investment opportunities within mutual funds. The repurchase or redemption price is the price per unit at which a mutual fund would repurchase the units, that is, buys back units from the investor. Finally, the sale price is the price payable per unit by an investor for purchase of units from other schemes of a mutual fund. Now, about the ISIN. What does ISIN stand for? It is the International Securities Identification Number. The first two letters of the ISIN code usually refer to the country in which the issuing company is based. Now, regarding the ISIN growth, so what is a growth stock? A growth stock is any share in a company that is anticipated to grow at a rate significantly above the average growth for the market. Moving on to how did we get here? So looking back as to how we ended up choosing 31 datasets out of 5,711 different datasets was that we did a systematic random sampling with an interval of 6 months. That is, we took the dataset of 1st January and 1st July of every year and we took those 31 total datasets. So even after taking those 31 total datasets, we found out that only 26 actual datasets were important, as the other 6 had NAN values, that is not a number or a missing value in the data, were found in the repurchase price and the sales price.
Let us walk you through the code. So, talking about the libraries being imported in pandas, some functions like read CSV reads the file from the provided location, then head and tail function will show first 5 and last 5 rows respectively from the data set. Info function plays a major role for information about our data, such as the column names, number of non-null values in each column, feature, type of each column, memory usage, etc. Using isNull and some functions, we can find the number of null values in a data frame for every feature. When column is completely empty, after seeing the sum of null values from isNull and sum function, so it will not provide any information which is beneficial to us. Hence, we will drop that particular column using the pandas drop function. Now, using the describe function, we can get various information about the numerical columns in our data frame, such as total count of rows, mean, the minimum value and the maximum value, and the spread of the values in the particular feature. Data collection consists of 6 basic steps. First, installing Kaggle, then uploading our Kaggle API token, followed by creating a Kaggle folder and giving permission for JSON to act, and finally downloading the data and unzipping the data.
The next step after data collecting is data preprocessing and cleaning. Data preprocessing involves transforming raw data to well-formed datasets so that data mining analytics can be applied. Data cleaning is a process through which a messy data is transformed in organized and corrected way. We did cleaning and preprocessing for every data in our sample, and here we randomly took 7 data to explain. First line of code reads the file. The second and third gives us the head and tail of dataset. Dot shape gives us the number of columns and rows, and dot is null round parenthesis dot sum round parenthesis gives us the number of null values in each column. Continuing the processing further, we have converted data type of scheme code from float to object because we don't want it to be present in data statistics part, and converting data type of net asset value, repurchase price and sale price from object to float value so that we get the statistics of that, and converted the non-NaN value to 0 in this 3 columns by the help of given code. Dot info gives us the complete info of the data set. Now we cleaned the data by dropping date, scheme name, ISIN div payout and ISIN div reinvestment.
Now for data cleaning and pre-processing, we come to visualization. So what is data visualization? It is a graphical representation of information and data in pictorial or graphical format in order to draw conclusions about the information in our data set. The various plotting libraries we have used are Matplotlib, Seaborn, and Plotly. Now let's look at the various plots we have used: box plot, scatter plot, line plot, histogram, and bar plot. Scatter plot is basically a plot containing values like minimum value of the dataset, first quartile, third quantile, and the maximum value of the dataset, and the median. Now, out of the 31 datasets we have taken in the sample, we are going to see the visualization of the first sample. First, we have plotted a line plot for the net asset value versus the sales price. We've also calculated the slope of this line, which is approximately equals to 1, because sales price is equal to applicable NAV times 1 plus sales slope. Sales slope is basically the percentage one pays while buying the shares. It usually varies from 0 to 5 to 6%. Similarly, for net asset value versus repurchase price, the slope is approximately equals to 1 again, because a repurchase price is given by applicable NAV times 1 minus of the exit load. Exit load is a percentage one pays while exiting from a mutual fund scheme. Now let's look at the line plots for sales versus repurchase price. Again, the slope is approximately equals to 1 because of the formula given in the previous slide. And looking at the graph of difference of the sales minus repurchase price versus the repurchase price, we again find that it is linear with slope is equals to 0. This is because in our data set, the sales price, repurchase price, and net NAV are approximately same with a few minor outliers. Now let's look at the bar graph to show and compare the NAV value of various schemes chosen in the data set. As you can see, we have plotted scheme name in the x-axis and the net asset value in the y-axis. Now, looking at the histogram of various quantities, which is NAV, sales price, or the repurchase price, we can see that for the first sample, most of these are scattered around the range of 1 to 20 only. And now looking at the box plot for the first data set, we can find that the box plot for NAV, repurchase, and sales price is almost same, and most of them values are near 10, except the some of the outliers.
Now we are going to see the descriptive statistics of the datasets that we have taken for analysis. For finding the statistics, we have used describe function from the pandas library. The describe method is used for calculating statistical data like percentile, mean, and standard deviation of the numerical values of the data frames. Let me give a brief idea of what describe function can do and what parameters it can take. The first parameter it can take is percentile. It is an optional parameter which is a list-like data type of numbers that should fall between 0 and 1. To put it in layman terms, it takes the input as what percentile values we want to calculate. Its default value is a list of 0.5, 0.25, and 0.75, which returns 50th, 25th, and 75th percentiles. The second parameter include is also an optional parameter that includes the list of data types while describing the data frame. Its default value is none. The third parameter exclude is also an optional parameter that excludes the list of data types while describing data frame. Its default value is none. In a code, we are using the default values for the describe function. The describe function returns the statistical summary of the series and data frame. Now we can see how the describe function works with our dataset. The describe function returns 8 statistical values for every numerical columns. The count represents the number of non-empty values in that particular column. The mean represents the average value of all values in a column. The STD represents the standard deviation of all values in a column. The min represents the minimum value of data in that column, and max represents the maximum value of data in that column. The 20%, 50%, and 75% represent the 25th percentile, 50th percentile, and 75th percentile of the data in that column, where percentile represents the percentage of data values that are less than the given percentile. We have plotted the mean, median, and standard deviation of net asset value, repurchase price, and sale price. From this, we can see that the mean and standard deviation of net asset value, repurchase price, and sale price are almost following the same trend for the datasets plotted. For median, the repurchase price and sale price follow the same trend throughout the plot, and net asset value follow the trend till dataset 21, but it highly deviates from dataset 21 to 24 and again follow the same trend after dataset 24. This is what we infer from the statistics of the simple random sample datasets which we took for the analysis. Thank you.
So after doing the data cleaning and processing, visualization and statistics, we will now test our analysis on the basis of hypothesis testing. So on the basis of visualization statistics, we analyze that the value of a dependent variables, that are repurchase price and sales price, are linearly dependent on the independent variable, which in this case is net asset value. Therefore, we will make a hypothesis regarding these three variables. For this, in Python, we use two libraries basically. One is spicy, another is statsmodel.stat. We use spicy to do t-test and statsmodel.stats for z-test. Now next, there are several tests we can implement. For example, t-test, z-test, chi-square, and ANOVA test. But at present, we will be doing only t and z-test because rest are for categorical data, and in our case, we don't have the categorical data. So now the t-test, even though we have implemented the t-test, but the thing is the t-test being implemented for the sample space less than or equal to 30. But since the sample space is greater than 30, our result for t and z-test will be same. Now we hypothesize two things. Our first hypothesis is that the mean of purchase price is equal to the mean of the net asset value. Corresponding to this, the alternative hypothesis is that the mean of the repurchase price is not equal to the mean of the net asset value. The other hypothesis is that the mean of the sales price is equal to the mean of the net asset value, and correspondingly, the alternate hypothesis is the mean of the sales price is not equal to the mean of the net asset value. Now we will do two-tailed test, and for that purpose, our rejection region is that in which the p-value or the probability corresponding to the hypothesis is less than or equal to 0.05. This will be our rejection region. Now we can do calculation regarding this using the formula as shown, and on that calculation we will get our z parameter. From the z table we can find the corresponding p-value or the probability value using the z table as shown here. Now, by performing the z-test, we concluded that for the hypothesis 1, we cannot reject the null hypothesis. And secondly, for the hypothesis 2, we conclude the same thing, that we cannot reject the null hypothesis. When we did this test for the remaining 30 files, we get the same result, that we cannot reject both these hypotheses for the respective files. So in that case, we conclude that the repurchase and the sales price are strongly related to the NAV value or the net asset value, and on the analysis based on the visualization and statistics, we can say that the magnitude of repurchase and sales price are equal to that of the NAV.